Hi there, and welcome to this video. Let's explore how we can generate DBIx result classes from an existing database using DBIx schema loader. Before we continue, there's just one small problem. We currently don't have a relational database set up that we can use to work with DBIx. So let's sort that out first. I'm going to be using MySQL database, but you can use other solutions such as Postgres to work with DBIx. So the next thing we need to figure out is where the database is going to be hosted. And here you have a couple of options. You can use cloud services like DigitalOcean or AWS to spin up a database instance. Another option is to install database server locally, or the option I will be using is to set up a MySQL Docker container. You don't need to have a prior knowledge of it. All you need to know is that Docker is free and awesome tool that allows you to run applications in isolated environments, aka containers. And this is exactly what we currently need. We want a MySQL database running on our machine that we can spin up and tear down without messing with our host machine. First thing you want to do, you want to go to your browser and just type in download Docker, and that's going to be somewhere at the top of the results. So if you click that, you're going to be presented with a page where you can choose appropriate Docker desktop version for your system. So for me, I'm currently on Windows, so that's what it offers to download. However, if you're on Mac or Linux, you can choose that. So hit download, install Docker desktop, and then run the Docker client. Know that you might need to create an account and sign in at this point, but as I mentioned before, that is completely free. Now once you have Docker installed, let's go to the terminal and let's type in Docker to make sure that everything is working as expected. And if you see the help menu, then that means Docker has been installed successfully. If not, then make sure the Docker desktop client is running. Now once that's sorted, we can look into spinning up a MySQL container. Docker containers are not expected to persist the data. So when we would spin up a database container, that data that we create would be deleted once the container stops. Before we run the container, I want you to create a folder where you're going to be working from and call that MySQL _data. We're going to bind this folder and tell it to store all the data related to the database. So every single time when we stop containers and run them again, that means the data is not lost and it's persisted in this folder. It's just going to be easier as we go through all the videos. Now let's go to the terminal and let's type docker run for running a new container and -- name. So we're going to choose a name for our container. I'm going to call mine MySQL, but you can call yours whatever you want. Then -p for port, and we want to say that on our host port 3306, we want to forward that to our container port where our MySQL database will be running. So currently MySQL listens to port 3300. Let's use the same port mapping. And basically that's just going to allow us to access the database from our host machine. Now we're going to use -v. And this is where that MySQL folder comes into play. We're going to say /MySQL data. So the folder we just created, // and then we need to specify a path where the MySQL client actually stored the data in the container. So that's going to be var /lib, another / and MySQL. After that, let's add -e for environment variable. And here we're just going to specify the password that we're going to use for our root user. It doesn't have to be anything secure. I'm just gonna call my password, but you can do that with -e and then capital MySQL _root _password equals, and I'm just going to say that my password is password. And after that, we can say -d, and that's going to run our container in the background in detached mode. Finally, we want to choose the container that we would like to spin up. In this case, I'm going to say MySQL, so MySQL : you can use latest, so it always pulls in the latest. But the cool thing about containers is that you can also pin a specific version number. So we want to say, in our case, that we want to use MySQL version 8.3.0. Now all of this looks good, and you can hit return. So this is going to take a little bit of time, the Docker to pull down the image, and from that image to spin up a container. Depends on your internet, but it shouldn't take too long. Alright, and looks like this completed. So if you run docker container ls, you should see one container running currently, which is under our image MySQL with version 8.3.0, and this is our container name, which is MySQL. Let's make sure that we actually can go into that container and we can connect to the database. You don't need to do the next steps. But if you want to sanity check that everything is set up correctly, you can follow along. Let's say docker exec, which is execute a command against our current container, -it for interactive terminal, and then we're going to say our container name, which is MySQL, and we want to say we want to execute bin bash. Alright, currently we're actually inside a container, and what we can do to connect to the database and make sure everything's okay, you can type MySQL -u for user, which is our root user, the only user that we have, -host for current host, which is 127.0.0.1, and -p for password. So let's enter our password. So I chose password before. If you chose something else, then you should enter that. But for me, it's simply password. So the password is password. Hit return, and we're inside the MySQL database. We can do something like show databases, and that looks all good. To note, you can connect to your database via terminal at any time, and the way we're doing it right now is completely fine. I will spin up another container for PHPMyAdmin that will give us an interface to query our data. It's just going to be easier for me to show the table contents and repeat queries through graphical interface. You can follow along and install PHPMyAdmin as well, but it's not really a requirement. We are currently into MySQL terminal, so let's exit that. We are still in containers, so let's exit that as well. And we should currently be on our host. And in order to install the PHPMyAdmin, we can run docker run as we did before. So --name, we name our container, which is going to be PHPMyAdmin, -d that we want to run it as well in detached mode. And then we're going to use this link to link these two containers, which is the PHPMyAdmin and the MySQL container on the same host. So basically, PHPMyAdmin can do all the magic behind the scenes, connect to the database through Docker network. So we're going to give it MySQL or container name and the reference, which is just going to reference it as DB inside the PHPMyAdmin. Then we say port. Again, we want to expose a port from our host machine to our container. Whenever we go on port 8080, we want to forward that to our container, which is listening on 80. And then we just specify which image do we want to run the PHPMyAdmin. In our case, is going to be PHPMyAdmin. All right, let's hit return. And for me, it's quick because I already have PHPMyAdmin on my side. It might take a second or two on your end. Once the process has finished fetching an image, you can do docker container ls, and you should see two containers running now. Now, how you can access the PHPMyAdmin interface is if you go to your local host, so local host port 8080, you should see PHPMyAdmin interface. And to connect to your database, you provide the same params as we did before. So it's going to be root user, and the password in my case is just password. Okay, great. We now have database set up, and I hope there were no issues so far on your end. It would be good to have a database, tables, and some data that we can use with the DBIx framework. I have prepared some simple SQL queries to create two tables, one for users and one for nodes. I will add those queries to the video notes. Let's quickly look at that SQL that we're going to run. As I said, it's actually quite basic. First thing is that we're creating a database, which is called nodes. And then we're going to be creating two tables. One table is going to store all the users that can create nodes, and they have simple columns, which is ID for their unique ID and their username, and the node itself. And it has ID as well for the primary key, then the user ID, which is going to be referencing back to the user table that created the node. Then we have description where you store the node body, and the important is just an integer where we can say that anything that has importance 1 is less important that has number of 2 or 3 or so on and so on. Now what we can do now, we can copy all that SQL. We can go to PHPMyAdmin and go to the SQL tab and just paste everything in. You can select all that content that we just pasted and just hit go. And if everything was okay, you should see a new database called nodes. If we explore what's in there, we're going to see we have a node table and we have a user table. As you can see here, we actually already have some data there, and this is because the last thing that we're doing is we are inserting a user, which is user 1, and then we're just creating 3 nodes, and we're doing that same thing again. We are inserting user 2 and just creating 3 more nodes. So altogether, what we have in our database are 2 users, and we have 6 nodes. So we have our database, we have our data, we have our tables, everything looks good. The final step to tie all this together, we want to generate DBIx classes that we can use to interact with our database through ORM pattern. Go back to our terminal. What we're going to need is a module which is called DBIx class schema loader. It's a long name, I know, but let's just type it all together. So if we say cpnm, that's what we have done before to install modules, and then the module name, which is dbic. So dbi, capital, lowercase x, class, schema, 2 more colons, and loader. If you hit return, it should take a second or two to get installed. I already have it, so it just says that it's up to date. Before we continue, we're also going to need MySQL connector in our case, because we're using MySQL database. If you're using something else, like Postgres, you should choose appropriate connector on your end. If we go to our browser, and if we go to MetaCPAN and look at the DB class schema loader, scroll down a bit, you can see there that there actually are a couple of connectors you can use to interact with the DB interface, such as DBD, Postgres, or DBD MySQL. In our case, what we're going to need, and a couple of more. Since we need the DBD MySQL connector, let's install that as well. Let's say cpnm dbd MySQL. And again, I have this installed on my end, so it just says it's up to date. And it's going to take a second or two on your end. You might face some issues regarding missing dependencies for this MySQL module. If that is the case and you're getting issues installing DBD MySQL, what you can do, you can go to your browser and search for homebrew MySQL to install all the necessary dependencies on Mac. If you're in a Linux system, as I am, currently Ubuntu, what you can do is you can say sudo apt get install lib MySQL client -dev, and that's just going to install all the necessary dev dependencies for MySQL to be able to connect to the database, fetch all the schema information, and generate the necessary DB classes. So if you just hit return for this, enter your password. In my case, I already have this as well, and it says it's just up to date. Try to run the DBD MySQL again, and it should be fine. The very last step we want to do now, after sorting out the dependencies, we actually want to generate those DB class files. If we go back to the browser and look at the DB class schema loader, you're going to see that you have a couple of options how you can do that. One thing is that you can create a script that you can run at any time, where you provide the connection information, is going to read your database schema, and it's just going to dump out all the necessary files in the specified directory. Alternative is that you can run it through command line, and it doesn't really matter which way do you choose to run this. For the sake of simplicity, I'm just going to go with option 1. I'm going to create a script file to make the schemas, and you can just follow along. I'm going to copy these lines from the documentation, go back to our working directory, and we can say that we want to create a new file, and we can call that dump.pl. Paste that in. You can always add our shebang line, so user bin environment Perl. You can use strict and use warning, pragmas, and then let's see what we actually need to change here. First parameter is how you're going to namespace your schemas. For example, by default, it's going to be namespaced as my schema and then the table names. If you have a specific application name like my app, feel free to replace this line with whatever is more appropriate in your case. I'm going to replace this probably with something like my app, but it doesn't really matter. Now the second parameter is going to be a bunch of config information. We want to dump our schemas into lib directory. So one thing you want to also do, you want to create a new folder, which is going to be called lib, where the schemas are going to be placed at. And now the default example that we had in the documentation is using the Postgres connector. So we're just going to need to change this slightly. So instead of saying DBI, we want to say capital DBI. Instead of Postgres, it's going to be MySQL. And I'm just going to replace everything that's after the DB name. Database equals notes. That's the database that we created. Host is going to be your local host, which is 127.0.0.1. And the port 3306, that's the MySQL default port. Now the user is going to be root, and the password is whatever you used. I just used password, so I'm going to put that here. Now the last thing, it doesn't really matter in our case, so we can just remove it. Alright, so that looks good. We have our schema loader set up. We have the config information specified. Now we can run the script. So if we say perl dump.pl, hit return, so it's not use strict, but it's use warnings, and rerun that again. So if we take a look, this is going to be our main schema, which is my app. If we go to the folders, we can see that we have our user result, where we have our ID, username, some column definitions that we added, which are ID, integer, username VARCHAR, and our nodes. So it looks like we can connect to the database and generate all the files necessary for DBIc. And the question, of course, becomes how do we actually now interact with the database using the DBIx framework and these generated files. Now, in the next videos, we will explore exactly that. We're going to look at the class row and class result set in more detail. And of course, we're also going to see how we can connect using Schema and use our DBIx classes. I hope you found this video useful, and I'll see you at the next one.